Hello, everyone, and welcome to the Ask the Expert webinar, Smarter Access to Open Data, introducing SAS access to DuckDB. My name is Tiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenters. First is Robin Thompson, a Principal Product Manager here at SAS. SAS specializes in data connectivity and integration within the SAS data management portfolio. He leads initiatives that enable seamless access to diverse data sources across cloud and on-premises environments with a focus on performance, security, and interoperability. Also on the call is Anand Bison. Here at SAS, he leads the Technologies Futures Group within the SAS Global Technology practice. This group specializes in advanced analytics, applied machine learning, cloud infrastructure, and open source software, and provides technical enablement for North and South America. Robin, please take it away.
Perfect. Thank you, Tiago, for the great introduction, and welcome to everybody that's kindly joined us today to hear about our new access product, SAS Access to DuckDB. So I'm going to take you just through a little bit of background, first of all, just about why we've done that, the changing landscape that we're seeing that's kind of driven us to this point, and really just focus on the value that this delivers to the platform. I then will hand over to Anand, my colleague, who's going to take you through more of the detail on actually how you make use of this and the value it can deliver to your organizations. So let's jump in straight away. This is everything I talked about is about SAS Via, and this is our kind of wide platform that allows you to bring the languages that you want to work with, delivers low-code interfaces, etc., and really just allows you to embrace that kind of open ecosystem as we move forward. What I talk about today is not part of SAS 9. However, you can use DuckDB within the SAS 9 world. You would just do it through other means, through ODBC and JDBC. Okay, so the landscape obviously is changing and is constantly moving over the years. You know, in the past, I guess the RDBMS, the database management system, things like Oracle, Teradata, IBM, etc., were the kind of real kind of big heavy hitters within there. And obviously, as you all know, we've been engaged and integrated with those for a long, long time. And I guess over the last 5 to 10 years, we've kind of seen the growth of the cloud warehouses. So things like Google BigQuery, Amazon Redshift, and Snowflake. Again, we've got great connectivity kind of for those platforms as well. Now, when we get into open file formats, they started growing, I guess, really out of the kind of Hadoop ecosystem, and many of things like Parquet started building in there, and some of these formats were really driving that kind of Hadoop ecosystem. But you know, over time, we've then seen, you know, as that's kind of built, as we then move to Iceberg and Delta Lake and Hudi and you know things like Duck Lake are kind of part of that, and really that's where this conversation starts to get really quite interesting. So these open file formats delivered a lot of great things within here: columnar storage, compression, really about query performance, how we can encode the data and definition of the schemas within there. And lots of different types of formats deliver, you know, lots of different capabilities. But really, what has changed from those is that we've kind of moved towards the kind of what we call open table formats. So how do we take some of the limitations of the files themselves, being immutable and often things like Parquet and stuff like that, and turn it into kind of more like a database system where we can do things like metadata management, time travel. How do I look at the data as it was last week or the week before, for example? How can we do the kind of standard transactions, update, insert, delete as part of that kind of thing? And ever-changing schema management as well as part of this. So how can I add additional columns to tables and those kind of files? So that's where really the open table formats have appeared. And really probably over the last 2-3 years, have been a bit of a battle between Delta and Iceberg, some would argue. But you know, we seem to be largely settling around about Iceberg within there, but each of them has their own merits within here. And recently, as we're talking about DuckDB, Duck Lake has brought something quite interesting to it, mixing the kind of standard format with a database within there, in that case, things like Postgres, to manage that kind of metadata within there. So these are the things that have been driving us, this kind of new landscape of how do we properly support a very fast-moving industry of open file formats, and particularly the open table formats like Delta and Iceberg within there. So how did we address this kind of challenge? And this has really been looking over the last kind of year or two, looking at this, really looking at what was available. It's not something we necessarily wanted to go and build directly ourselves because, we would have to put so much resource into it. So we're very focused on how we can involve open source within VIA these days. We are more and more open than we've ever been in the past, and this was a great thing. So we've been looking at lots of different elements in there, things like DuckDB, also things like Trino and other technologies where could we embed that within it to deliver the capabilities that we're seeing within the open format. So looking at all of that, DuckDB has been a really interesting one, and I guess it's been around for a little while now. Came, I guess, version 1 of the kind of open source in 24 within there, but really been built, obviously within Europe, within the Netherlands, by some industry experts who were looking about how do they deliver an analytical database performance without needing huge volumes of IT equipment to go along with that and clustering, those types of things. It's definitely a class-leading performance for an in-process query engine at this point in time. Struggled to find anything that kind of competes with it in this space. From a SAS point of view, it's MIT licensed, so there's no future risk from our point of view. It will, it's been written in such a way that it will maintain and stay as open source, and that will continue to develop and moves really fast, actually. But if that was to change in the future, then obviously we could pick up that code and continue to maintain it for our own purposes, but no plans to do that at the moment. An interesting bit here is the ecosystem of extensions. So initially we set out in this is how do we support Parquet and things like Iceberg and Delta, but the ecosystem that goes alongside of this expands hugely. So it supports everything from JSON to CSV. It supports databases in there. It's got drivers for Teradata and Snowflake and these types of things within here, and a kind of wide group of things that are being built and ever expanding. And all of those you can use now from within SAS. How we've chosen to deliver this is as a SAS access interface to DuckDB. Now, typically an access engine means you go and install something on the side and we connect to that thing. In this case, DuckDB is embedded, so there is no additional install or configuration required. Within VIA, you get access to interface to DuckDB just as default, so it's there. There's no additional cost as such for DuckDB to be included. And we're continuing to develop it. But currently within R&D, we're looking to upgrade to the very latest version at 1.4.1, which will give us things like insert, update, and delete for Iceberg. But the ecosystem keeps developing. We will continue to do that development alongside of this. Okay, so what is, if you haven't heard of DuckDB, there might be some people out there haven't. It's very, it's an exciting time, but you think of it almost as this kind of SQLite of analytics. It's very lightweight and it's saying you can run this thing on your laptop if you want. It's an in-process analytical database. So albeit it does, and you can land database files, etc., but you can also run it in process, so you don't necessarily need to be landing your data. You can work with the data and push your queries down to where those files exist. It makes great use of columnar storage, obviously Parquet, etc. within that, really optimized for analytics, and really fast scanning and aggregate joins, etc. So if you're starting to do SQL with things like Parquet, etc., it is lightning fast. And again, that's built on by its vectorized execution that goes along in terms of the way it chunks up that data for CPU efficiency. So you will get much more from the resources you have. You will make much more use of the CPUs that you're paying for, perhaps in your cloud infrastructure. Flexible data access means you don't have to move your data around. If that data is sitting in S3, you've got perhaps Iceberg or Parquet or CSV, for example, sitting in there. Well, let's query it in place. So no need to move that data into SAS. Let's push the queries down in there and just do what we want with those results, either write it back into other files formats or take it into other processes within SAS VIA, and maybe go on and build models, etc. beyond there, or build reports perhaps from there. So really flexible. It is embedded, so there's no additional server required. It's not like you're going with Oracle or Teradata, go and install it. It's already included within here. And it can be used from Python R or really any application within there. So it is really open in terms of its structure. As I say, it's open, cross-platform, it's open source, it's perfect for what we're now doing with VIA these days. So that's DuckDB. So when we bring it into DuckDB, and VIA's already said it's an access, but it's seamlessly integrated. Talked about this already. There's no additional thing to manage here. Once you get your VIA installed, it's ready and you're ready to go. Unified access, it's a single product that covers a huge number of different formats of files here. So you can use a single access product, query your Parquet, your Delta Lake, Iceberg, JSON, CSV, the list goes on and on. You know, Excel, there's extensions for all of these things, and now you can use that through one point through our access to DuckDB. One of the interesting bits is you could be using SAS and also Python. It allows you to then start getting into that kind of world of that kind of one connector, connecting the two things, and these kind of two worlds of open format will all neatly work together here. So really bridge your workflows across of this with DuckDB at the center and part of the VIA ecosystem. And as I say, we've already spoken about it. The performance boost is huge, and Anand will touch upon some of this. And Anand's been working with many of our customers to look at this, and the improvement in performance we can see over traditional methods is vast. So that drives a kind of different way of working. You can work in very large data sets, get those answers you're looking for very, very quickly. And finally, it shouldn't be seen as DuckDB is absolute everything here. With VIA, you also get all of the scalability, governance, and all the kind of deployment that you would expect. So it's part of SAS VIA. It's not a replacement for. So you may go on and build ETL type flows using DuckDB, for example, and all this great stuff you get within Studio, for example, and then go on and use perhaps visual analytics to visualize the data. And our kind of model studio as well, if you wanted to build predictive models, perhaps, and AI models with that kind of thing. So it's part of this kind of wider VIA ecosystem, but it does deliver great benefits. Why it matters, again, a little bit of repeating here, but faster insights, no heavy ETL required. We can query directly into the formats that data is stored. So we don't need to convert it. We don't need to move it. We can send our queries directly to there, so it delivers much, much faster. Interoperability, we can use the same capability. It supports SAS, it supports Python and other ecosystems in here. Again, using open file formats is part of that kind of world. Cost efficiency is something Anand will talk on more about. So obviously, avoiding duplication of data is a big one, but it also allows us to think about how we're storing the data. One of the big drivers for things like Parquet is its kind of small size and its compression ratios over other technologies within there. So that's a big part of it, and Anand will go through a lot of the detail within there. So again, query where it is, avoid duplicated data, drives cost efficiency. And finally, future-proof. So we've delivered this deliberately with open source because we get that innovation. There's a big community around about DuckDB at the moment. We're also involved in it ourselves. And it's built inside this kind of robust platform of SAS VIA. So really future-proofing. As we move forward, there will no doubt be new file formats and new etc. in the future, but we would expect this to keep up with that. Okay. So that's a very quick overview. Now you're going to get into the kind of probably the really interesting stuff you hear about today, and Anand will take you through that detail on how you could go ahead and use access to DuckDB. Anand.
Thank you, Robin, for the introduction. So I'll go ahead and talk about some specifics in terms of how DuckDB has been integrated and how it would look from a vantage point of a SAS user, right? So here, what I have in front of you is a SAS VIA's compute infrastructure, where you have these compute pods. And these are Kubernetes containers where you log in and you run your SAS compute session. So prior to SAS via 2025 July release, what you have is a SAS runtime that kind of executes your SAS code, and that comes with a base engine. And a base engine allows you to access your SAS datasets, like SAS7 BDAP files. Now, post July release, there will be a DuckDB live name engine in addition to base engine. And what a DuckDB live name engine will allow you to do is to read Parquet, JSON, CSV files on the same file system. So at this point in time, once you upgrade your environment from prior to 2025 07 to '07 or later, you automatically get access to DuckDB. Now, you have not changed any of the infrastructure, and you can access these additional file formats from your compute engine. Now, what this live name will also provide you is the ability, and I'm sorry, the formatting is slightly off on my screen, and I apologize for that if it is for you as well. But what it would also allow you to do is access open table formats and the same Parquet, CSV, and JSON files on object store in a cloud native manner as well. So if you already have an environment where you are using S3 buckets, for example, to store your data sets in full fidelity, you can just go and take the analytics or SAS analytics right then and there and query the data sets from the location. Now, DuckDB live name engine has 3 different targets that it can work on. So the first target is in-memory format, where it is ideal for kind of performing small ad hoc analysis, where if you are materializing small results from aggregation, for example, you can use in-memory format where you don't really have to specify a destination on a file system to store your data sets. Now, it is ephemeral, and one of the use case would be if you are kind of running an aggregation or group by on a data set, which you want to consume in a downstream analysis and then not preserve the materialized formats on a file, you can use in-memory format. Now, you need to ensure that the data set that you're working on is smaller than the available memory that you have. The second target that DuckDB allows for is, again, a DuckDB format, but on a file system. And you can place that in any file on a file system. And in this case, you can work on data sets that are much larger than the available memory on your compute session, for example, because DuckDB works very well with in-memory as well as out of core, because it has a streaming engine where it does not have to load the entire data into memory before it can execute or process your data. Now, these DuckDB files are multi-table files. They are very portable, so you can basically take the entire experiment and host all of the files inside a single DuckDB file, which can be kind of shared with other users that are using SAS or even Python and R, because there is the DuckDB native library that can consume DuckDB formats from other ecosystems as well. And last but not least, you can also use the DB engine, and this is where a lot of excitement is, to natively read data in full fidelity in form of CSV files, iceberg tables, JSON or Parquet files. So how does it work from a SAS user's vantage point? So we have wrapped this engine in our live name interface. So if you are a SAS programmer, it will feel very natural to use DuckDB. If you look at the 3 instantiations in front of you right now, the first one, which is the simplest, live name, a name of your libref and DuckDB, would instantiate and connect to a in-memory instance. And from that point onwards, you can just create and work with this ducklib library as if it were any other SAS lib name. The second example is where you are saying, I want to materialize the tables that I am creating on disk because I want to use it for later analysis, for example. And here you specify database equals to work.db or the path of where you want to save your file. And that is where all of the tables that you will materialize inside that lib name would be materialized and saved. And the last one is if you want to ensure that the target location already has Parquet files, or you just want to work with Parquet files, you can specify file type equals to Parquet and specify a path where you want to save all of these output or resulting data set in a Parquet format. So once you have defined your lib name, post that, it works just like any other lib name engine. So for many cases or most cases, if you already have an existing code, it would be mostly changing lib name interfaces with a few exceptions, mostly changing lib name interfaces, and almost all of your procs should work as they have been working. Now, you also get some additional advantages, which you don't really have to use, but you can kind of slowly get into it is, for example, the idea of globbing files. So if you are a SAS user, you may be accustomed of creating views across multiple data sets so that you can kind of work on those multiple different SAS7 BDAF files as if they were single ones. With Parquet and DuckDB engine, it's very easy to use a globbing characters to kind of specify the target files that you want to operate on. So in this case, for example, here I'm using 2012/star.parquet. And all it says is, hey, for running this analysis, go inside the subdirectory 2012 and treat all of the Parquet files that you find there as if it were a single table. And it kind of makes ad hoc analysis extremely fast because you don't really have to kind of merge all of these data sets together before you can perform your analysis. Last but not least, if you are an existing DuckDB user, you also have the ability to use their native SQL dialect and use a explicit pass-through to SQL. And what that does is it allows you to kind of tap into the modifications to SQL that they have performed, which can kind of work out or where you can create really powerful data patterns. For example, I really like their exclude clause, which is let's imagine you have 100 columns. You can say select star, exclude column 1, column 2 from the table name. So instead of listing out 98 different column names, you can just say exclude 2 columns. So it kind of makes your code very readable and manageable. Alternatively, they also have multiple different functions that are not traditional SQL. For example, if you want to read a JSON file, so you can specify read underscore JSON and path of the JSON file, and you can work with a JSON file as if it were a SQL table. So all three of these mechanisms are supported and exposed right from within a SAS code. So now a couple of examples that I just mentioned. Lib name, name of your library reference, DuckDB is the minimal syntax that you'll be using to start DuckDB from SAS. This creates an empty library. And once you have created a library, you can use a SAS data step or a traditional SAS proc right on that library reference. As I said, data in memory is temporary. And as soon as you end the session, all of the data in memory would be ephemeral and would disappear. The second example where you specify a database file, and this database option materializes a file on a file system so that you can use it for your subsequent sessions. It creates a file if it does not exist. And if it does exist, it will start consuming and you will start seeing all of the tables that are inside that file. .duckdb is really not it's not required. It's a convention. You can use any name. And in this case, we are using the same data step, and the file yt.yellow trip data will be materialized inside that file. Now, when you're talking about a DuckDB file, you have to realize that DuckDB files are a single user access. So if you are on a shared file system, either you open a DuckDB file in a read-only mode so that multiple readers can work from that file. But if you have opened your DuckDB file in a read-write mode, only one user will be able to access that file. So this is a single user access mechanism that DuckDB supports. ProcSQL is where you will see significant performance gains when you are using DuckDB. It is absurdly fast because of the way it handles vectorized processing, and it leverages columnar data set on the file system by eliminating even scanning a lot of files if a lot of the data if your query is not dependent upon those parts of the data. And SAS does push down SAS functions down to DuckDB so that the data is processed inside DuckDB, thereby eliminating large amounts of data moving back to a SAS session for just performing those functions. So SAS functions are kind of mapped to DuckDB query processing engine, and the processing takes place inside DuckDB query engine. Now, performance is one part, but the other part is just enabling new different workloads. As I kind of briefly alluded to, globbing characters, for example, is a very powerful data pattern. And we talk about parquets a lot, but lately we have been coming across JSONs over and over again with the advent of generative AI and natural language processing environments, or even IoT, where JSON files are just very pervasive. And DuckDB offers an extremely performant mechanism to process these unstructured JSON files in place, right? And from enabling new workflows perspective, if you look at this query here, where I'm saying, select star from ducklib star/star.parquet. What it says is, hey, go to this directory and find all of the parquet files in all of the subdirectories and run the query that I have specified. Now, this is, in this example, I have 12 years of New York taxi dataset, which is 156 files, one file per month. Now, if I want to perform analysis on just year 2012, either in a previous incarnation, I mean, I would have to kind of create a single file consisting of all of those 12 individual files before I can perform my analysis, which is kind of a heavy operation, right? Both from an IO perspective as well as from a compute perspective. But now if I change this part with 2012/star.parquet, from the get-go, I have eliminated reading or even scanning 92% of the data sets. And I can just operate on the 12 files that are of interest to me. And you can get really creative when you're talking about different kinds of analysis. Let's say, for example, I want to perform my analysis only on the last month of every year. With this globbing character, which is star/12.parquet, I can eliminate again 92% of the entire data set, or scanning 92% of the data set, and just operate on the 12 files that I'm interested in. Or in this case, I can eliminate 85% of the data and just focus on the 24 files that I need to work on. So it kind of makes your ad hoc analysis, or the latency to perform these kinds of analysis extremely fast. It also allows for powerful deployment patterns, because now you don't really have to merge and perform expensive ETL operations when you get new data, because new data means dropping a new Parquet files inside a directory and treating all of those Parquet files as if they were a single data set. The second, as I said, processing JSON dataset kind of comes to SAS in a very performant manner. And gone are the days when you had to first load the entire JSON objects into a tabular structure, which is cumbersome and problematic in of itself. And then you would process, these are the columns that I need to work on. What DuckDB allows you to do is, because of its streaming engine, you really don't have to kind of load the entire data set into memory before you can identify, the columns that you're interested in for downstream analysis. And I will give you an example here where, where we are taking Amazon reviews dataset, which is in a gzipped format here. And this consists of 43 million reviews and 22 gigabytes of data. Now, here I have converted accessing this data deployment pattern converts accessing JSON file as if it were a SQL database, where I'm saying, hey, read JSON, read this gzipped file in JSON-L format, and I'm specifying the columns that I'm interested in. I am performing conversion or transformation of timestamp here and just selecting the rows or columns that I'm interested in, and also filtering out reviews where the rating is less than 2 and the verified purchase is false. So let's say I'm trying to identify which are the fraudulent reviews, and I'm not really interested in low rating where I cannot verify if the reviewer had purchased the item or not. And while at it, I'm also writing out a Parquet file. Now, this is not really a formal benchmark, but I was able to process all of this on a relatively normal compute session in 1 minute and 52 seconds. That's 400,000 rows of processing per second on a compute environment where the size of memory was much less than the size of the dataset. That's pretty fast. Now, again, not a formal benchmark, but I went ahead to CMS website and I downloaded a data set for provider summary. And I kind of implemented both of or this workflow, which is kind of reading the CSV or gzip CSV and creating a SAS7 BDAT file as if I was using pure SAS without DuckDB. And then I was using pure SAS with DuckDB Access Engine and how they would differ, right? So here I'm reading the data set that is provided by CMS. I unzip it. So the data set is 480 megabytes in this case. If I unzip it, it becomes 3 gigabytes. Then I read this 3 gigabytes and convert it into a SAS7 BDAT file. And that SAS7 BDAT file becomes 10 gigabytes. Performing sort operation on that would create another 10 gigabytes file. So all in all, I have performed 20, I end up with 24 gigabytes of data set and perform around 36 gigabytes of IO operation on my subsystem. Now with DuckDB, I can ingest directly from a gzip CSV file and create a Parquet file, which results into another 480 megabyte file and perform a sort operation, which is again for 480 megabytes. Now you can see there is significant reduction in the requirement of infrastructure, both in terms of bandwidth and capacity. And the outcome here, if you look at the overall runtime, is significant gains when we are talking about processing CSV files, importing them into a Parquet file. Now, if I use proc sort, which is not changing code at all, keeping everything as is, even proc sort, because of the fact that you're just reading so much smaller file, and coupled with the vectorized processing of DuckDB, you will see that there is significant gains, which is 3.3x in terms of the performance of proc sort on the same data set. The third line is when I'm performing sort operations, but using proc SQL, order by. And now, once you are ending up with a much smaller file, all of the other SAS procedures like proc free, proc means, proc tablet automatically becomes a lot faster because you're operating on just a smaller amount of file or data set on the file system. Now, that we have a smaller data set, how does that transform to infrastructure cost savings, right? So I mean, this is again a sample scenario. I mean, if I am in cloud and if I have 100 terabyte of SAS data sets and I'm using, let's say, NetApp Ultra, it's going to cost me approximately $500,000 annually based on list price to save that 100 terabyte worth of data. Now, if I do not modify my infrastructure, and if instead of SAS 7B, that if I were using Parquet files as the file format, based on the compression rates that we are observing, because of the way data is stored in columnar format, there are advantages in Parquet in terms of how they encode and compress the data. And I use the same NetApp Ultra infrastructure on a cloud. Now I am saving 75% less capacity on the same infrastructure. And that's 75% saving purely from compression and encoding advantages or benefits of Parquet that we are getting. And in addition to the capacity, we're also freeing up a lot of IO throughput because now we have to just read so much fewer amounts of bits to perform the same operation. And if we take it further and take this 25 terabyte of data set and save it on an object store, for example, AWS S3, where just the cost of that infrastructure is much different, which is around 2 cents per gigabyte per month. Now I would have to spend approximately $6,000 annually for saving the same data set that was costing me close to $500,000 in NetApp Ultra on SAS data sets. So you get best of both the worlds. Number one, we have wrapped the DuckDB processing engine in LiveName, so you don't really have to learn a new language or new dialect. Your existing code would mostly work as is, and you get the performance advantage as well as the cost advantage in terms of infrastructure cost savings. With that, I would be happy to take any questions if there are any.
Yes, thank you. With that, we will be moving into the Q&A portion of the webinar. Okay, now on to our first question here. Why are open file formats and columnar query engines critical for modern data ecosystems?
For a couple of reasons, right? If you look at a columnar file format, it's a file format that self-describes the structure and provides enough metadata so that a query engine or a computational engine can access just the right parts of the data without unnecessarily reading the entire data set, right? So that's number one. And number two, it also provides an opportunity to perform parallel operations or engaging all cores to work on the data in parallel. Now, when you get to a modern data stack, these stacks are deployed on cloud infrastructures that are kind of distributed across different data centers. And you really have to be very conscious as to how much data you are moving and how you can get the most from infrastructure where it's not capex, it is operational expenditure, and you're paying based on the consumption model, right? So these columnar file formats in a modern data stack are very conscious of how you can derive or extract maximum amount of investments from the infrastructure. So they're just much more efficient.
Sure. Thank you. We have another question here. How does SAS Access interface to DuckDB simplify analytics for technical and business users?
I'll take that one. So, I mean, essentially, it's one access engine that supports a huge number of different file formats. So, as Aaron's spoken a lot about Parquet, but obviously JSON, CSV, it's kind of one place to go to support all of those kind of elements. It's really open. It supports that entire ecosystem. You can either use the implicit SQL, where we'll convert the kind of SAS syntax into the DuckDB syntax, or for a kind of wider set of capabilities, explicit SQL is your friend, so then you can use the entire DuckDB framework within there. So it's a simple place to start with huge, powerful performance.
Perfect. Thank you. We have a question here. In an agentic AI ecosystem, how can we be able to achieve persistent memory by using DuckDB?
I'm not sure I understand the question. So in a agentic AI ecosystem, how can we be able to, sorry?
How in a agentic AI ecosystem, how can we be able to achieve persistent memory by using DuckDB? We can also ask the person to reword the question and resubmit if they'd like to.
Yeah, I would like to double click on this question to get some more specifics before I can answer.
Okay, no problem. Another question here. What competitive advantages does SAS Viya offer in an open, evolving data landscape?
Well, it provides a single unified platform and brings in all sorts of analytics available to the practitioner without having to kind of jump in across multiple ecosystems to perform their tasks. So you can really build extremely complex workflows from this platform. And from a organization's perspective, it provides you with the governance and security that one would expect from an environment like this. So I think it's a melting pot where SAS Viya brings in a governed platform where you can kind of access all sorts of data and perform your analytical magic.
Perfect. Thank you. Another question here. Someone saying, you mentioned S3 storage. Does it support Azure Data Lake storage?
It does partially today, but a complete Azure Data Lake access is part of the plan development.
Okay. Slightly similar question here. Someone's asking, does it support authentication for AWS and Azure?
It does. It integrates very well with IAM and Azure Entra.
Okay, thank you. Another question, does SAS Viya support downloading and loading DuckDB extensions, whether they are core or community extensions?
Yeah, the simple answer is yes. we are looking at how we include some of the key ones so they don't have to be downloaded all the way from DuckDB's website, particularly for dark sites where they have no internet access, for example. So we'll give alternate methods, but the simple answer is yes. Some of that you may have to do through explicit SQL, but yes is the answer.
Gotcha. Thank you. Someone's asking, are you likely to integrate with Mother Duck in the future?
So there's no specific plans for it at this point in time, so it's not actually on the roadmap. However, I have done some testing myself with that, and it seemed to operate perfectly well just through either ODBC or JDBC and that kind of method. So I have done some tests, but it's not specifically on the roadmap. If that is something people are interested in, I encourage you to kind of raise feature requests for that, and we'll look at that in more depth.
Perfect. I'm afraid that's all the time we have for questions today, but if we did not get to yours, we will answer all unanswered questions in our follow-up communities post. Thank you both for your answers, and thanks to everyone in the audience for joining us today. On behalf of myself, Anand, Robin, and all of SAS, we really hope that you enjoyed today's webinar. Thank you all, and have a great rest of your day.
Thank you all.
Thank you.